All right, this unit is about the mole, and we're going to go ahead and start with formula and molecular mass. So, when it comes to, we've learned already that atoms have mass, and so you can look at the periodic table to figure out the mass of each atom. So, for example, the mass of hydrogen, if you look at the periodic table, is 1.01 AMU. And this is just easily shown if you look at the periodic table, the average atomic mass, and so on. So we could keep on going, and you'll see carbon and oxygen. So if you look at carbon should be 12.10 AMU, and then oxygen is 16.00 AMU. So each atom has a mass, and they're in the mass is measured in atomic mass units. Before we continue with mass, so we need to know the difference between a molecule and formula and a unit. And basically, a molecule is a compound, a covalent compound. So remember, covalent compounds are between nonmetals. So here we carbon dioxide. So remember, nonmetals are anything to the left of the, or I'm sorry, not left, but to the right of the zigzag. And then a metal is to the left of the zigzag. So an ionic compound, we're going to now call a formula unit. So there are examples. So anything with a metal is going to be called a formula unit. Any compound that are just nonmetals are going to be called molecules, okay? All right, so now we want to be able to figure out, is there a mass? Can you figure out the mass of carbon dioxide, a molecule of carbon dioxide, or sodium chloride? Well, if we know the mass of each individual element, then it's really easy. We just need to add up however many atoms of each element there are to determine the molecule or the formula unit. We have specific name, like molecular mass versus formula mass. So, molecular mass is the sum of all atomic masses in a molecule. So, for example, for water is H2O, right? So, the molecular mass of water is going to be the mass of 2 hydrogens and 1 oxygen, right? So there's 2, there's 1 oxygen. If we look for hydrogen, the mass of 1 hydrogen is 1.01 AMU, for oxygen is 16. So this gives you 2.02. This gives you 16. Add them together, you get 18.02. Now what about for formula units? This is the sum of all the atomic masses in a formula unit. Sodium sulfate, so let's write what sodium sulfate. Sodium is Na plus 1, sulfate is SO4 minus 2. So this is Na2SO4. So, how many sodiums are there? Well, there's 2 sodiums. First thing I do actually is I just write out how many elements I have. So I have 2 sodiums, so 2. And then I have 1 sulfate and 4 oxygens. So sodium is Na 22.99. Sulfur is 32.07, and oxygen is 16.00. So get out your calculator and do some math. And you add them all up. So the formula mass for sodium sulfate is 142.05 and then AMU. So one one formula unit of sodium sulfate is 142.058. All right, so here are some practice examples as well. So let's go ahead and try this. I'll give you the answers and you can go ahead and try. So calcium carbonate, lead 4 nitrate, sulfur dioxide, carbon tetrachloride. So those are your examples. Calcium carbonate has 1 calcium, 1 carbon, and 3 oxygens. So calcium is 40.08 plus carbon, which is 12.01, plus oxygen, which is 16 times 3. So this gives you 100.09. Next one is we have 1 lead. Actually, this is going to be a little tricky. I have 4 nitrogens and 12 oxygens. So lead is 207.2 plus nitrogen, which is 14.01 times 4, plus oxygen, which is 16, and I have 12 of them. Altogether, this is 455.24 AMU. Let's look at sulfur dioxide. I have 1 sulfur, 2 oxygens. 32.07 plus 16 times 2. This gives you 64.07. Carbon tetrachloride. Carbon is 12.01 plus chlorine. Chlorine is 35.45 times 4. 153.81 AMU. Okay, so you can check your answers. Okay, before we move on, it's kind of useless to find the mass of one atom because we can rarely isolate one atom. It's not like we really don't need to know the mass of one atom. We need to use units that are bigger. In the lab, it's not like we just take a tweezer and use one atom. We use bigger amounts. And so instead of talking about atoms, we're actually going to use a descriptor. For example, like a dozen. When you talk about a dozen something, that means there's 12 of them, or a couple means that there's 2. Well, in this case, we're going to use a mole. So a mole is like a dozen. When I say a mole of something, that means it's a number of something. And that number is 6.02 times 10 to the 23rd. It could be atoms, ions, formula units, molecules. We need such a big number because this helps us, because the atom is so small, we actually need a lot, we need quite a bit of atoms to even get to a place of the amount that we use in the lab. So we don't ever use one atom. We actually use, the tip of your pencil has probably billions of atoms. And so we use larger amounts, so we need a kind of a unit that will help us use that larger amount. So instead of saying, oh, I have 6.02 times 10 to the 23rd atoms, which is kind of a mouthful, we just say, oh, I have 1 mole, or I have 2 moles of this, or 3 moles, or 2.5 moles. 6.02 times 10 to the 23rd is known as Avogadro's number, named after the guy who kind of came up with this number. Here is actually a little video on the mole. It's actually pretty interesting. All right, so now that we deal with moles, we're not going to worry about formula mass or molar mass. We're going to worry about molar mass, meaning 1 mole is equal to this mass, okay? And it's actually equal to the formula molecular mass in grams. So instead of in AMU, it's going to be in grams. So, for example, the molecular mass of water is 18.02 AMU. We did that already. So therefore, the molar mass, or the mass of 1 mole of water, is 18.02 grams. And then this is basically what we're going to use. If you understand this, then we're in good shape. 18.02 grams is our molar mass. So therefore, that's what it equals 1 mole. So our molar mass always equals 1 mole of that substance. And remember, 1 mole is just 6.02 times 23rd of whatever that thing is. Here's some practice.